Let's look at how to show the first conditional. Of course, since we're showing a conditional, we're going to be using the rule CD. And so I'll put over here as CD. And I'll want to be showing the consequent, which here is a disjunction. And that's really what the point of this discussion is. How do I show that disjunction? Now, I'm going to just copy that disjunction over here, just so we can see what it looks like. And you might ask yourself, and you should ask yourself first, can I use addition to derive Q wedge P? Well, to use addition, I'll need either Q or I'll need P. And it's easy to see that given my only available line is line 3, that I could never derive Q and I could never derive P. The reason for this is that P wedge Q could be true and Q false, and similarly P wedge Q could be true and P could be false. But it's impossible for them both to be false, and that's the key. So instead of doing addition, I will have to use the other alternative rule for this, ID. I think I'll just erase this to make it a little easier to see. So I'll put show consequent here. And since I'm going to be using an ID argument, I can put as ID here. Now my goal here, of course, is, as always, is to derive a contradiction. But if I look at tilde Q wedge P, I immediately should see that by De Morgan's law, this is equivalent to tilde Q and tilde P. And if I have De Morgan's law, I could just derive it, 5dm. Done. And then the rest of the proof would be very easy. I could derive now by simplification 6SL, 6SR, and then I derive my contradiction by 3, it doesn't matter, 7 or 8, 7 MTP, which will give me my contradiction. And if I want, I could then put 8, 9 ID, and I'd be done with deriving the consequent. But if you don't have DM, and that certainly is the case if you're deriving DM, you can't use it. So what do we do? Well, the way to do this is to think, well, regardless of whether I have DM available, I know that DM is true. I know this because my system is complete, that everything that is semantically valid is also syntactically valid. So I know that I should be able to derive tilde Q. Well, given that I know that I can derive tilde Q and tilde P as well, I should be able to do it. So I'll just put show tilde Q. Now, again, I look over here and I see that there's no way that that is a direct derivation, and I'm deriving a negation, so I will use, again, an ID argument. I'll pick Q. The trick here goes back to a point I've emphasized several times, namely, when you have a really ugly negation, you know that that's going to be one of the contradictories. Moreover, you know that since this is equivalent to tilde Q and tilde P, you are only going to be using this. P wedge Q is out of the picture in this argument. So, if I bring this down, we can see it a little more clearly. I need to derive the negate of tilde Q wedge P. And nothing is easier. How? Well, I use adjunction. Here I'll just write it in, add to the right, P, to derive the negate. Notice that in using this argument, I do use addition, just not in the obvious place. And now I have my contradictories, 8, 9, ID. Now, once I have tilde Q, nothing is easier than to derive my contradiction. Here I can look back, and I know that I'm now going to be using P wedge Q, and so I'll use MTP to derive P, 3, 6, MTP. And I don't have to derive tilde P. All I have to derive is, again, the negate of line 5. So that here, too, will be 11 addition. And here we'll add to the left Q. And now I have my contradictory. I have the negation and its negate. So I can put 5, 12, ID. And if I want, now I can finish the this part of the proof by putting 4 CD. Now, in this case, the second part of the derivation will be exactly the same, just switching things around a bit. But in general, this won't be the case. Nonetheless, the technique is the same. Again, use your knowledge of De Morgan's law to find out what you need to derive, tilde Q and tilde P, or you could find a shortcut. But basically, that's what you're going to be doing. Then use MTP to get your contradictories. Again, here, you will be using addition. Why? Well, because somewhere in deriving a wedge statement, there should be a use of addition.